The purpose of this video is to refamiliarize you with the Pythagorean Theorem and actually prove why the Pythagorean Theorem works, and introduce you to a theorem on triangle inequalities. So just a little revisit of the Pythagorean Theorem. Remember that a right triangle contains two legs and a hypotenuse. In any right triangle, the hypotenuse is always the longest side of the triangle and it's opposite the right angle. So in this particular triangle, side xy would represent the hypotenuse, and the two sides that form the right angle are called legs. So we have two legs and one hypotenuse. And you should recall from your previous math courses that in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared. We want to go through, and now that we're into some deeper levels of math, we want to prove exactly why and how come this works. And in order to do that proof, we're going to go ahead and we're going to start with some right triangles. And these right triangles are going to have legs of lengths A and B, hypotenuse of length C. So what we're going to do is we're going to start with 4 copies of that exact same triangle, the legs of lengths A and B, the hypotenuse of C. And what we're going to do is we're going to arrange these triangles to form a square. So this square, if we go through and label the lengths of the other sides, A is the longer leg, B is the shorter leg, right angles are right there, C is the hypotenuse in each case. So again, B is the shorter leg, A is the longer leg. So what we've done is we've created a square where the length of one side of the square is going to be A plus B. Notice this says this part should be removed before copying for students. That's my faux pas. But at any rate, I'm going to go through and walk this through with you. We can figure out the area of the large square. So I want to do this big, giant blue square in 2 different separate ways. We could say, well, the area of a square is always equal to length times width, or base times height, or side times side, however you want to think about it. One side of the square has measure of A plus B units. So the area of that square is going to be A plus B, the first side, times A plus B, the second side. And when we go ahead and apply distributive property to this, A times A gives us A to the second. A times B gives us A times B. B times A is the same as A times B. And B times B is B squared. So we've got an A squared plus a 2AB plus a B squared for the area of that large blue square. The other way we can find the area of this square is by taking the areas of all these little pieces and adding them together. So in my picture, the area of that purple square is going to be C times C, or C squared. And the area of each triangle is going to be 1/2 times the base times the height. Or in other words, 1/2 times A times B. But I've got 4 of those. So I've got 4 of the 1/2 times A times B plus C to the second. Well, 4 times 1/2 is 2. So 2AB plus C squared. Now I've calculated the area of this large blue square in 2 different things, or in 2 different ways. So those 2, by substitution, have to be equal to each other. So I'm going to go ahead and set those expressions equal to each other. And just like it says, work my little algebraic magic. So if I go ahead and subtract 2AB from both sides of my equation now, we've got your old familiar Pythagorean theorem that you've known all along. A squared plus B squared equals C squared. Now, the next time that you come back to class, we're going to be utilizing this to find out some different things about some different kinds of triangles, and to solve problems that involve right triangles. You can use the Pythagorean theorem to determine whether a triangle is a right triangle or not by seeing if it works. If the sum of the squares of the two sides is exactly equal to the hypotenuse, then we know or we can conclude that the triangle is a right triangle. If, however, the sum of the two squares of the sides is greater than the length of the hypotenuse, we can conclude that the triangle must be acute. And if the sum of the squares of the two legs is less than the hypotenuse, we know that the triangle has to be obtuse. All right, so that concludes the first part of today's video. The second thing that we have to look at is triangle inequalities. And you may or may not have seen this in middle school. If you did and you remember it, great. If you didn't see it or don't remember it, that's okay too, because it's really not that difficult. It just says that in any triangle, so notice this is for any triangle, not just a right triangle. So this triangle inequalities work for right triangles, but they also work for acute triangles, obtuse triangles, isosceles triangle, any kind of triangle that you can imagine. It says the sum of any two sides must be greater than the length of the third side. So in other words, the two smallest sides, if I add them together, must exceed the length of the third side. And we might use this simulation on mathwarehouse.com when you come back to class just to see what happens. But for now, we're just going to go ahead and look at some problems that involve this triangle inequality. So which set of numbers could represent the lengths of the sides of the triangle? I have to look for the two where the sum of the two smallest is greater than the largest. So if I look at the sides in the first one, the two smallest are going to be 11 plus 8. So I want to see if 11 plus 8 is greater than 19. And the answer is no, it's not. Those cannot be the sides of the lengths of a triangle. Two smallest in number 2 are 5 and 5. If I added that together, I have to see if it's longer than the third side. And the answer to that is no. So those can't be the sides of a triangle. Two smallest in the third example are 4 and 3. And if I add those together, I have to see if they're longer than the third side. And they're not. Two smallest here are 19 and 16. And if I add those together, I do get something that's greater than 20. And since that finally works, I can conclude that that's my answer. So that's how that works. The other thing that you need to know with respect to these inequalities is that for any triangle, the longer side will always lie opposite the larger angle, and the larger angle will always lie opposite the longest side. The only thing that I'm going to caution you on here, make sure before you draw any comparisons that you know all three side lengths or all three angle measures. All right, so in the first example, I want to know which would be the longest or the largest angle in that triangle. Well, the largest angle in that triangle is going to lie opposite the longest side. So the largest angle is angle B. And then the smallest angle will lie opposite the smallest side. So the smallest angle here is going to be angle C. In the second triangle, they've given us angles, so we want to draw or make a determination about side lengths. But before we do that, we have to make sure that we know the measures of all three angles. Right now, we're only told the measures of two angles. Because I know that the three have to sum up to 180, I can deduce that this third angle measures 74 degrees. And only once I know the measures of all three of those angles can I go and make some determinations about the lengths of their sides. So I want to find the longest side, and I want to find the shortest side. I know the longest side will lie opposite the largest angle. The largest angle in this case is angle Z, so that's going to make my longest side, side XY. My smallest side will lie, or my shortest side will lie opposite the smallest angle. And since 52 degrees is the smallest angle in that triangle, side XZ will be the smallest or the shortest side in that triangle. If you have any questions, as always, please feel free to rewatch the video or make a note in the margin so that you can remember to ask about them the next time that you come to class. The next time that you come to class, we'll actually be looking at the application of some of these ideas involving Pythagorean theorem and triangle inequalities.